Okay, we're going to talk about 3.5 nonlinear systems of equations and define systems of nonlinear equations. Well, really that system means you have two or more equations. And if it's nonlinear, that means at least one equation is not linear. All right, so nonlinear systems. So pictorially, you can have, well, first you can have three different possibilities in the systems we're going to talk about. We're going to deal with the forms y equals mx plus b, that's actual linear. We're going to deal with the form y equals ax squared plus bx plus c, our quadratic, and then we'll actually deal with the form x minus h quantity squared plus y minus k quantity squared equals r squared. Okay, and that is our circle. So just some of the examples. Non-solution in pictorial form. A no solution would mean maybe you have a quadratic, a parabola that opens up and then down, and they just never intersect each other. Or maybe you have a parabola and a line that never intersect. The same thing could be with a circle. Okay, a parabola and a circle that never intersect, or a circle and a line that never intersect. One solution, maybe you have a parabola and a line segment that intersect in one spot. Okay, and that one spot maybe is right there. Or possibly a parabola and a parabola that intersect in one spot. They touch in one spot, maybe right there. Okay. Or maybe even you just have a circle and a line tangent to a circle. And if you recall that, that just means a line intersects that circle in one spot. Or a parabola just hits the circle in one spot. Two solutions. Let's get a couple examples here. Maybe you have two parabolas. And maybe you have one that opens up, one that opens down, and they intersect in two spots. Or maybe you have a parabola and a line cutting through that parabola, say like so. Or just maybe you have a circle and a line cutting through that circle, like so. Okay, those are all would be examples of two solutions. Okay, well, let's see. Let's go ahead and try to solve this. I'm going to walk you through solving systems by graphing, by substitution, elimination. In fact, I'm going to use the same system 3 different times. So graphically, what I've done is I've shown both of these plotted. I used Desmos to do that. So you'll notice I put my equations in, I plotted them, and they intersect. They intersect right here and right here. That means the solution to this system would be the ordered pair, negative 2, 9. So this one here, and the ordered pair 1, 0. Those are both solutions. And recall, really what that means is I can substitute those values in, and it would make both of these statements true. So for instance, if I put in 1, 0, I'd have 1 squared plus 4 times 1 minus 5, and that should equal whatever y is, in this case 0. And notice 1 plus 4 minus 5 is 0. That works. So that worked in the top one, and I could try it in the bottom one. It would be 1 squared times negative 2 is negative 2 plus 1 plus 1. Well, that should equal 0. And notice negative 2 plus 1 plus 1 equals 0. So it works twice. It works in both equations there. And you can test in negative 2, 9, and it would also work in both of them. I'm not going to go through that, but it does. So these are my solutions to that system, negative 2, 9, and 1, 0. Okay, now like I said, I'm going to use the same system, but I'm going to solve it using elimination. Now remember, when you're using elimination, you are actually eliminating one of your variables. So I stack my equations like so, and I look at them and go, well, do I have any opposites? Well, I don't, and notice here I'd have to have opposite x squareds and x's if I wanted to eliminate x, but it's pretty easy to eliminate y if I were to multiply either the top or bottom equation by -1. In this case, I'm going to multiply the bottom one by -1, so that's just going to change that sign to negative, that to positive, that to negative, and that to negative. And now, to go ahead and add these two together, negative or positive y plus negative y is 0. So 0 equals x squared plus 2x squared is 3x squared. 4x plus negative x is 3x. And -5 and -1 is -6. And let's get that -6 there. And so notice that leaves you with a quadratic equal to 0. Now I could factor that, or I could try to factor it. So first thing I'm going to do is take a 3 out. So 3 times x squared is 3x squared. Oops. Okay, and 3 times x is 3x, and 3 times -2 is -6. So from there I'll look at this, whoops, boy, it just erased a piece of my thing. Holy moly. Okay, I'll look at this quadratic piece right here. I'll say, well, what two things multiply to make -2 and add to 1? And in that case, I have -1 times 2. And so that's going to give me the 3 still out there, and I have x minus 1 times x plus 2 equals 0. This is going to give me a solution of x minus 1 is equal to 0, so x equals 1. And this is going to say x plus 2 equals 0, so x equals -2. And those are my two solutions for x, -2 and 1. Well, then I have to take one of my equations. Maybe I take that first one there, x squared plus 4x plus 5, or minus 5, that top equation. And I substitute these values of x's in. So, and that's going to give me y. So if I put 1 in for x, that's going to be 1 plus 4 minus 5, and 1 plus 4 is 5 minus 5 is 0. So when I have an input of 1, or a value of x for 1, I get an output, or a y value of 0. That's one of my solutions. And then I'm going to go ahead and do it again. Y equals x squared plus 4x plus or minus 5, but I'm going to put in -2. And so that's going to be y is equal to -2 quantity squared plus 4 times -2 minus 5, or 4 minus 8 minus 5. Well, 4 minus 8, that is -4, minus 5 is -9. Okay, so on this one, I got an input of -2, an output of -9, or x is -2, y is -9, and those are my solutions. Notice those are the same solutions, 1, 0, -2, -9, that we had over here. 1, 0, -2, +9. So did I mess up here? 4 minus -8, and just double check my work here. Nope. Did I mess up over here? Oh, I did. For crying out loud. Didn't even catch that. So in this one, our solution wouldn't have been -2, +9. It would have been -2, -9. Unbelievable. All right, well, hopefully you guys caught that. I didn't catch it immediately. Okay, so using substitution is our next step. So we've used graphing, or elimination, and now substitution. And notice now, both of these equations equal the same thing. Y, x squared plus 4x minus 5 equals y. -2x squared plus x plus 1 equals y. Therefore, if I can set this equal to this, because they both equal y. So using substitution, I say, well, x squared plus 4x minus 5 equals -2x squared plus x plus 1. And now I collect my x squareds on the same side, so I'm going to move these two x squareds over. Okay, that's going to give me 3x squared plus 4x minus 5 equals x plus 1. I'm going to move this x over now. That's x. Okay, so I get 3x squared plus 3x minus 5 equals 1. Now I'm going to move this 1 over. And so now I have 3x squared plus 3x minus 6 equals 0. Okay, well, I look at that and it's quadratic. I can go ahead and factor out that 3, and I'd have x squared plus 3, or plus x, excuse me, minus 2 equals 0. Okay, now I'm going to bring this right over here, because now I'm going to have 3 times x squared plus x minus 2 equals 0. Should look a little familiar, because that's what we just had, but 2 things that multiply to make negative 2, add to 1. That would be 2 and negative 1. So we have 3 times x plus 2, x minus 1 equals 0. This is going to give me negative 1. This is going to give me positive, or excuse me, negative 2. This is going to give me positive 1 as a solution. Okay. So I'm going through this fairly fast, because notice these x values right here are those same x values, negative 2, 1, that we ended up with here. And then we would just substitute them back into our original equations. Now I'm going to use the other equation this time, negative 2x squared plus x plus 1, to just show you it won't matter which one I use. So if I go y equals negative 2x squared plus x plus 1, I put negative 2 in first. So y equals negative 2 times negative 2 squared plus negative 2 plus 1. Well, notice this is negative 2 squared is positive 4 times negative 2 is negative 8 minus 2 plus 1. Well, that's negative 10 plus 1, or negative 9. So I have an input of negative 2 and output of negative 9. That is one of my solutions. That matches this solution right here. Excuse me. And then if I had y equals negative 2x squared plus x, my plus 1 there, and I put in 1, I get an output negative 2 times 1 squared plus 1 plus 1, or negative 2 plus 1, which is an output of 0. Okay, so when my input is 1, my output is 0. 1, 0 is my other solution, and notice that's the one that matches right there. All right, so you've had all 3 methods. You have graphing, or elimination, and substitution. Okay, so now you can use any method, and I really only have 3 problems here. Okay, so solve using any method, and you'll notice on this one I have an x squared and a y squared and a y, and then I have an x, a y, and nothing else. So I look at this right away and I'm like, well, I could get x by itself pretty easy in this bottom equation. I could go ahead and add 3y over and add 3 over. So whatever I do to one side, I have to do to the other. That would end up giving me 0 and 0, and x would be 3y plus 3. So I solve this bottom equation for x. And now I can take this, whatever x equals, and substitute it back in right there for x. So if I rewrite that now, let's go ahead and switch colors here. I'd have 3 times x, which is 3y plus 3 now. And then don't forget that squared. Plus 2y squared minus 54y minus 143 equals 0. And so now I look at this and I'm like, okay, I've got to simplify this left-hand side. I'll square this first. So this really is 3 times, 3y plus 3 quantity squared is 9y squared plus 18y plus 9 plus 2y squared minus 54y minus 143 equals 0. Okay, so this is like FOIL right here, right? For those of you who are like, well, what did he just do? That's just 3y minus 3 times 3y minus 3. Okay? Or 3y plus 3, excuse me, times 3y plus 3. All right, so now we'll distribute. Okay, so we get 26y 27 y squared plus 54y plus 27 plus 2y squared minus 54y minus 143 equals 0. Okay, so I start looking at this, try to condense some stuff. So I get 2y squareds and, or 27y squareds and 2y squared, so I have 29y squareds. And so 29y squareds. I have a 54y and a negative 54y. That means they cancel. And I have a 27 and a negative 143. And 27 plus negative 143, that is, see here, 116, negative 116. And all that's going to be equal to 0. Alright, so now I'm just going to solve using roots. I'm going to add 116 over 29y squared equals 116. I'm going to divide by 29, so y squared is actually equals to 4. 116 divided by 29 is 4. And I'll take the root. Okay, so y is equal to plus or minus 2. Square root of 4 is 2. So y equals plus minus 2. Okay, well that would be great, except for that it doesn't tell us what x is. So really, I just circled it saying, yeah, I'm done, but really I'm not done. Okay, we've got to actually now substitute it in for x, both of those values in for x, and solve for y. And I'm going to use the bottom equation for that. Okay, so I'm going to look at this, say, well, x minus 3y minus 3 equals 0. I'm going to put in 2, so x minus 3 times 2 minus 3 equals 0. So that is x minus 6 minus 3 equals 0, or x minus 9. Oops. See, I got thinking ahead. It's x minus 9 there. 0, so that's x minus 9 equals 0, so x equals 9. Alright, so when my input was 2, my output was 9. So I get the order pair 2, 9. There's one solution. And I could go through and do it again here. And I'd have to put in a negative 2 this time. So we'll go ahead and do that right here. I'll say, okay, x minus, notice x equals 3y plus 3. So I'm actually going to use that one. So I don't use it right away to I don't want to confuse you, but I've manipulated up here to say, put it in. I solved for x already. So I could have done that here and it saved me a lot of steps. You'll see how quick it is here. Okay, so that means 3 times negative 2 plus 3 is negative 6 plus 3, or negative 3. It's a little faster. So when I have the input of negative 2, I get an output of negative 3. Those are my two solutions. And I could test them, and they would both work out in there. I've already checked them. Okay, oops. There we go. All right, so our next one, go ahead and draw a line here. Our next one, I'm going to solve the bottom equation for y, because I look at the top and I could solve for y there, I guess, too. Oh no, because I got the y squared. I guess I could solve for x, but it'd be real ugly. So I'm going to solve for y. I'm going to go ahead and move that 4 over and then subtract 2x. Okay, so I get y is equal to negative 2x plus 4. And that means I can take this, what y is equal to, and put it in for y here, and put it in for y here. All right, and so let me go ahead and switch up some colors here. So in my top equation, I'd have 4 times y, negative 2x plus 4, squared. Don't forget that squared. Plus 34x plus y, or negative 2x plus 4, minus 52 equals 0. All right, and then that would be 4 times, and if I use FOIL here, that's going to be 4x squared minus 16x plus 16 plus 34x minus 2x plus 4 minus 52 equals 0. Okay, distribute there, there, and there. So we get 16x squared minus 16x, oops, excuse me, not minus 16x, but minus 64x. Plus 64 plus 34x minus 2x plus 4 minus 52. Holy moly. Okay, let's start simplifying. So we got some x squared there, and that's it. So 16x squared. We've got a negative 64x and a positive 34x, which is going to give us a 32. Oops, 34. Oh, there's minus 2 more. So 32x. Negative 32x. And then we're going to have the rest, 64 plus 4 is 68 minus 52, which is 16. All equals 0. Then I look at that and I'm like, hey, I can factor out a 16. So 16 times x squared minus 2x plus 4, or plus 1, excuse me. Equals 0. And I can factor that now. So 16 times x minus 1 and x minus 1 equals 0. Fantastic. X equals 1 then. Right there or right there. Okay, x equals 1. Which means I can take what, to find y, I just use this equation right here. Okay, well if x equals 1, I know y equals negative 2x plus 4, or it equals negative 2 times 1 plus 4, or negative 2 plus 4, which is 2. Y equals 2, which means I have the order pair 1, 2. Only one solution here. There, got it. Now remember, all these represent some kind of picture. Okay, think of our pictures back here. Okay. So one solution is going to be probably something like this, because we had a linear and we had I think we had a circle there. I'd have to look at it again. I think I had an x squared and a y. No, I just had a y squared. It did have an x, yeah. So, all right. So quadratic and linear there. All right. One more. Find the number of real solutions. Oh, key term there. Real. Can't have imaginary. All right. So on this one, I'm going to use any method here. In fact, I think just looking at this, I might use elimination, because it looks like they could eliminate y real easy. Could eliminate y if I multiply maybe the top equation by negative 1. Okay, that would just distribute in, or really, more importantly, just flip all your signs. So this would become positive x, negative y, and negative 4. So negative 1 times negative x, positive x, negative 1 times positive y is negative y, negative 1 times 4 is negative 4. This equation on the bottom just stays the same. I'll just rewrite it. Now be careful, because when I look to combine these, add these two zero out. This over here gives you negative 1. You can't add these. This is x to the first, this is x to the second. So I actually have x squared plus x. I just have to put those next to each other. So I look at that, and that's still a quadratic. So if I write it in ax squared plus bx plus c equals 0, that would mean I'd have to just move this 1 over, add 1 to both sides. Right? Okay, balance it out. So that'd be x squared plus x plus 1 equals 0 now. And now I look at that, and so I can't factor it, so I have to use one of my strategies: completing the square, factoring, graphing, quadratic formula. Well, I can't factor, I don't want to graph, I can't use square roots because I have a b term, and completing the square would be tough because my b term is 1. Nice for that to be even, so it leaves me with quadratic formula. So I'm going to list a, b, c. Okay, and a is 1, b is 1, c is 1. That makes it pretty darn easy. Okay, and then I'm just going to solve. X equals opposite of b plus or minus square root of b squared minus 4ac all over 2a. And that gives me negative 1 plus or minus square root of 1 squared minus 4 times 1 times 1. It's real easy when they're all 1s. All over 2 times 1, which really is negative 1 plus or minus root of 1 minus 4 over 2, which means I have negative 1 plus minus the root of negative 3 over 2. Whoa, we have a negative. Now that means I have imaginary solutions, which means if it's asking for the number of real solutions, or find the number of real solutions, or find the real solutions, I can't do it. There are no real solutions. The only solutions I have are imaginary. I'm just going to stop there once I recognize it's imaginary. And for those of you like, why is it imaginary again? Because you have a root of a negative, okay? Which used to be no solution before we knew what imaginary numbers were. And now we look at it and go, hey, those are going to be imaginary solutions. All right, well, that's it. Good luck.